afternoon to all. This is Neelima. I am studying Junior BPC. Please keep away your examination tension first, and later we will be coolly listen my lesson. Okay. First one, before we know about our topic, first we should know some relatives of our topic. In the first relative, rigid body. I wrote down on the board. Look here. In such relatives, first one is rigid body. Rigid body. I hope you already know about it because it is a general thing. Rigid body is a body with perfectly definite and unchanging shape. Okay. It is very simple. It is a body with perfectly definite and unchanging shape. But in our universe, there is no particular rigid body because all rigid bodies can deform under the influence of force. But in some cases, this deformation is taken as negligible. I hope you got it. Once again, I explain what is rigid body. See here, it is a body with perfectly definite and unchanging shape. But in our universe, there is no particular rigid body. All rigid bodies can deform under the influence of force. Okay? This is the first relative of our topic. Next one, center of mass. This is also very simple to know. Every body has some mass. The total mass of the body seems to be concentrated at one point. Such point is called center of mass. Before we write down our note, see example for the center of mass. This is the example for the center of mass. This body has some mass. Okay? Is it correct? Yes. This body has some mass. Okay? See here. This total mass of the body concentrated at this point. Concentrated at this point. This point is called center of mass. Okay. So I write down on the board the definition. The total mass of the body seems to be concentrated at one point. Okay. Once again I explain the center of mass. The total mass of the body seems to be concentrated at one point. That point is called center of mass. I hope you got it. This is very interesting topic. Next, these are the two relatives of our topic. Okay. Next one is, the third one is center of gravity. Center of gravity. The center of gravity means the total weight of the body seems to be concentrated at one point. Such point is called center of gravity. Okay? I will write down on the board. The total weight of the body seems to be concentrated at one point. Okay. Such point is called center of gravity. Example for the center of gravity. This is very simple to remember. This is chalk piece. This have the center of gravity refers weight. Okay. This has some weight. The chalk piece put on the table. The total weight of the body concentrated at the base. Okay. This point is called center of gravity. This base point is called center of gravity. Okay. You got it? Next one is, fourth one is moment of inertia. Before I tell the moment of inertia, I want to tell a small story. Okay. Once I am traveled in a bus. Suddenly the driver do brake. Also I am suddenly bent and hit the front seat. Then I got headache. Okay. Why I am like that? I think. Then I come to college and ask my physics teacher, what is that moment? Then my physics teacher tell to me that is property of every body, that is called inertia. Okay. Everybody has it. I ask a question to my physics teacher. Then my physics teacher replied to me, yes, it has everybody. It have everybody. Okay. Moment of inertia means the change, to oppose any change in its state. Okay. Inertia, to oppose, it is a property of body. Okay. Inertia is a property of body. To oppose any change in its state. Okay. Once again I repeat what is inertia. Inertia means to oppose any change in its states. That is called inertia. Okay. We are able to know moment of inertia now. Moment of inertia means the inertia of rotating body. The inertia of rotating body is called moment of inertia. Okay. Inertia refers to rest bodies. Example for the rest body. The ball is in rest. So, it is example for the rest body. It has property of inertia. Okay. Next, it rotate. This also have inertia. That inertia called moment of inertia. Okay. Inertia of rotating body is called moment of inertia. Okay, these are the relatives of our topic. Once again, I repeat the relatives of our topic. See here, from the charts we know what is the relatives of our topic. Okay, first relative is rigid body. Okay, it is a body with perfectly definite and unchanging shape. Okay, there is no real body that is truly rigid. Are you follow my words? All real bodies deform under the influence of force, but in many cases this deformation is taken as negligible. Okay, this is the first relative of our topic, rigid body. I hope you got it. Next one is center of mass. For a rigid body or system of particles, the total mass of the body seems to be concentrated at particular point. That particular point is called center of mass. Okay, such point will behave as if it is the total representation of the translational motion of that body. Okay, this is the second relative of our topic. And the third one, this is very easy to know. I hope it is understand to you. Next, center of gravity. It is the point in the body where the total weight of the body seems to be concentrated. Such point is called center of gravity. Okay. If we apply an equal and opposite force to weight of the body, then the body will possess both translational and equilibrium and rotational equilibrium. Okay, this is the center of gravity. This is third relative of our topic. Next one is moment of inertia. The inertia of rotating body is called moment of inertia. Okay, moment of inertia mathematically represented as I equal to sigma I small I equal to 1 to n mi Ri square. Okay, here it is equal to capital Mr square, because here m is the mass of the only small particle. Okay, sigma m is the summation of the particles. Okay, so the total mass of the body is represented by capital M, and R is the distance between the axis on the points. Okay, and taken any point in the given plane, that is equal to capital M R square. We already know about inertia. It is very important thing. Inertia, it is the property of body to oppose any change in its state. Okay, simply inertia means resistance to change. Mass of the body M is measured by the inertia. These are the relatives of our topic. Now, I going to explain our topic, important topic. It is very interesting to listen. Okay. My topic is parallel axis theorem. Parallel axis theorem. First, I want to tell importance of this theorem. This theorem applicable to any shape of the body. First importance is this theorem applicable to any shape of the body. Any shape of the body. Did you understood? Next, this theorem allows to find the moment of inertia of axis, okay, given the moment of inertia of axis passing through the center of the mass. This theorem allows to find the moment of inertia of a body. Okay, this theorem applicable to any shape of the body, and this theorem allows to find out the moment of inertia of a body about any axis. Okay, given moment of inertia of axis passing through the center of the mass. This theorem has statement. Okay, this theorem may be stated as follows. Listen carefully. This statement is very important to all. The moment of inertia of a rigid body about any axis parallel to the axis passing through the center of the mass, and it is equal to the sum of the moment of inertia of axis passing through the center of the mass and the total mass of the body multiplied by the square distance between two parallel axes. Okay, this is the statement of this theorem. Statement: the moment of inertia of a rigid body about any axis parallel to the axis passing through the center of the mass is equal to the sum of the moment of inertia of a axis passing through the center of the mass okay, and the total mass of the body multiplied by square distance between two parallel axes. Okay. Once again I explain this theorem. Statement: the moment of inertia of a rigid body about any axis parallel to the axis passing through the center of the mass is equal to the sum of the moment of inertia of axis passing through the center of mass and the total mass of the body multiplied by the square distance between two parallel axes. This is the statement of this theorem. This theorem mathematically expressed as I equal to Ic plus mr square. Okay, this is the mathematical expression for this statement. I is the moment of inertia of body about any axis. It is equal to the sum of the moment of inertia of axis passing through the center of the mass and the total mass of the body multiplied by the square distance between two parallel axes. This is the statement. Okay. Now, I go for explain the proof. Okay. For prove this theorem, first we should consider a rigid body with mass capital M and with center of mass G. One of the axes passing through this center of mass, that moment of inertia is indicated with capital IZ. Okay. Next, another parallel axis passing through the point. It is a new axis passing through the point O. Its moment of inertia is indicated with capital I. Okay. The distance between these two parallel axes, is R. Next one, we take any point in the plane as P, like this. We take here, this point is indicated with cap P. Okay. Now, we join OP and GP. We join OP and GP. Next, we extend the line OZ like this and draw a normal from the P. This meeting point is indicated with capital D. Okay. This is the example for this is the rigid body. Okay. We considered it is a rigid body, center of mass G. Axis passing through this point with a moment of inertia is capital IC and another parallel axis passing through the points O. Its moment of inertia is indicated with capital I. Okay. The distance between two parallel axes is R and take any point in the given plane as P. Next, we extend the line OZ like this and draw normal from the P. The meeting point is indicated with capital D. Okay. For roughly, we draw the diagram. It is a rigid body with mass capital M. Okay. With center of mass G. We already know center of mass. Okay. Axis passing through the center of mass with moment of inertia capital IZ. Next, another parallel axis passing through the point O. Okay. This moment of inertia is indicated with capital I. The distance between these two parallel axes, is indicated with capital R. We take any point in the plane as P, then join OP and GP. Okay. Next, we extend the line OZ. Like this and draw normal from the P. Then meeting point is indicated with capital D. Okay. Now we prove this theorem. Okay. Here we want the moment of inertia of body about any axis. Okay. That moment of inertia is indicated with capital I. From the diagram we know this. Okay. Here moment of inertia of body about any axis is denoted by capital I, that is equal to sigma m OP square. This is from, I am already telling that moment of inertia formula sigma m r square. Okay. Sigma m, I am already telling that r is the distance between point on the axis and any point given in the plane. Okay. Here point on the axis is O and given point in the plane is P. So square distance between these points is OP square. Okay. So we write OP square. This is equation number 1. And next one, the moment of inertia of axis passing through the center of the mass, that is indicated with capital Iz, that is equal to sigma m Gp square. Okay. G is the point on the axis and P is the point taken in the given plane. This is equation number 2. For prove this theorem, we take triangle, we take in the triangle OPD. Okay. From triangle OPD, according to Pythagorean theorem, hypotenuse square equal to side square plus side square. Here hypotenuse square is OP and other side is, one side is PD and another side is OD. Okay. Here hypotenuse is OP and one of the side is PD and another side is OD. So according to the Pythagoras theorem, OP square equal to PD square plus OD square. Okay. OP square equal to PD square plus OD square. This is the equation number 3. We already know OD value from the diagram. Okay. Here OD value, OD equal to OC plus GD. Okay. Okay. Once we draw the diagram,